Previously, we've talked a lot about integers, and now it's finally time to have a short look at fractions and decimals. Fraction a over b is basically a division a by b. A is called numerator and b is called denominator. So the important note is about equivalent fractions, which means that the same number can be represented as an infinite number of different fractions. So equivalent fractions are created when you multiply or divide numerator and denominator by the same number. For instance, if we have 6 over 8, we can multiply 6 and 8 by 5 and we get 30 and 40 at the top and bottom respectively. So 30 over 40 is still the same number as 6 over 8. Or we can also divide 6 and 8 by 2. So when we divide 6 by 2, we get 3, 8 by 2, we get 4. So 3 over 4, or 3/4, is still the same as 6 over 8. And 5 and 2 here are just examples, but I actually can divide or multiply by any number and get infinite number of equivalent fractions, which means if you need a specific denominator or numerator, you can always create it by multiplying or division. And now let's look closer at properties of fractions. So how can you do basic arithmetic operations with fractions? Let's start with adding and subtraction. To add or subtract, you need to be sure that you have the same denominator. If you don't have it, just create it by multiplying or dividing, as we discussed before. So when you have the same denominator, which is also called common denominator, then add or subtract numerators only and leave the common denominator. For instance, we have here 6 over 8 and 3 over 7. Just to make it more simple, firstly, I simplified 6 over 8 and I got 3 over 4. And then I add 3 over 4 plus 3 over 7. They have now different denominators. The common denominator for 4 and 7 is actually their LCM, as I hope you remember from the previous lesson. So the LCM of 4 and 7 is their product, 28. So instead of 3 over 4, I now get 21 over 28. Instead of 3 over 7, I now have 12 over 28. And 21 plus 12 is 33. So the result is 33 over 28. Or we can also write it as a mixed number if it's needed for your problem. For example, we have answer options as mixed numbers. So 33 over 28 is 1 and 5 over 28. Well, so adding and subtracting fractions is actually the hardest thing about them. Now let's have something more relaxing. Multiplying is kind of straightforward. To multiply two fractions, you just multiply numerator by numerator and denominator by denominator. But before that, I strongly recommend you to simplify as much as possible before you get into multiplication. So here, as an example, we have 6 over 7 times 3 over 8. And before I rush into multiplication, I see that there is 6 and 8, and they both can be divided by 2. So I divide 6 and 8 by 2, I get 3 and 4 respectively, and then now I need to multiply 3 over 7 times 3 over 4. And now I only multiply 3 and 3, 7 and 4 to get 9/28 as a result. And the last thing about a fraction is how to divide them. To divide them, you basically need just to multiply by the reciprocal of the divisor. A reciprocal is the flipped over version of a fraction. For example, I have here, if your fraction was a over b, reciprocal will be just b over 8. So to divide, you just need to flip the second number and multiply. Here we have an example, 9 over 10 divided by 3 over 5. And I flipped 3 over 5 to get 5 over 3. And before I rush into multiplication, I simplify. And I get, instead of 10 and 5, 2 and 1. Instead of 9 and 3, 3 and 1. And here what do we have? The second number is just 1 over 1. So multiplying by 1 is still the same number, 3/2. So what you need to get from here that fractions, they may look a bit scary, but like test wants you to simplify as much as possible, and before you start any operation, simplify, and then you will have kind of nice numbers. Now let's move forward. So now we know how to deal with fractions, and now let's just have a look at some special properties which make your life even more easier. So first of all, you need to remember that division by 0 is something which is not defined. So fraction, something over 0, doesn't exist. And then if you divide a number by itself, if this itself is not 0, so then you just get 1. And if you divide by 1, you have the number itself. And important way to see this property, then when you have just a number, for example, like 8, yeah, okay, you may represent the number as this number divided by 1 if you need to create a fraction from the integer. And then if you need to get a reciprocal, or if you need to get 1 over a fraction, which makes even a bigger fraction, don't get scared. You just need to flip the fraction. If you divide 1 over a over b, it's just b over a. And have a look at the example. So if you divide 6 over 0, stop and don't do that because it's not defined. And then if you divide 6 over 6, that's 1. And you can only do that because 6 is not 0. And then 6 over 1 is still 6. Or if you need to represent 6 as a fraction, you may write that 6 is 6 over 1. And if you need to divide 1 over 3 second, that's 2 over 3. And now we will have a really brief look at decimals. Decimals are also fractions, but they're usually written with the decimal point. And there are two major kinds of decimals. That's finite decimal. For example, 0.75, which can be represented as 75 over 100, or a 3/4 if we simplify the fraction. And there are infinite decimals. For example, 0.66666 and the infinite number of 6. And it's periodical decimal because 6 is repeated. That means that we can also write it as 0.6 in parentheses. And this represents that 6 is repeated. And if we write that as a usual fraction, that 2 over 3. So when you divide 2 over 3, you will not have a finite decimal. It will be like infinite decimal, 66666 and so on. But when you divide 3 over 4, you will have kind of nice decimals at 0.75. That's basically what you need about how they're created in GRE. And now let's examine how to deal with decimals. Before that, I want to remind you that you can use calculator on the GRE test. And if you're not sure how to do some calculations with the decimals, you can easily do them on your calculator. But if you want to be a bit faster and you're confident with your decimals and your calculation skills, then you can use this remainder. So if you need to add two decimals, for instance 0.37 and 0.044, write them one by under 1, because it will make it easier not to lose any decimal place. So we firstly add 4 and 0, because on the thousandth place there is nothing in the first number, so it's just 4. And then 7 plus 4, it gives us 11, which leaves 1, and 1 we just remember. And then 3 plus 1 from the memory is 4. So we get as 0.414. Then to multiply two decimal fractions, you need to actually multiply their values without any zeros. So if you have 0.25 times 0.3, just multiply 25 times 3 to get 75. And then you need to separate as many decimal places as there are in total in the first and the second number. So in the first number, 0.25, there are 2 decimal places. In the second number, 0.3, there is 1 decimal place. So 2 plus 1 is 3, which means in the result you need to have 3 decimal places. That's why I have 75 and 0 before it, just to ensure there are 3 places. And the last thing about division of 2 decimals. So to divide 2 decimals is the best way is to write them as a fraction and then multiply it by 10, 100 or 1000 just to get rid of a decimal point. In this example here we have 0.75 and 0.3. So I multiply by 100 numerator and the denominator and I got 75 over 30. So you see I got rid of the point and then I just simplify. The first thing I simplify by is 5 because I saw, okay, 75 and 30 are both divisible by 5 and I get 25 over 10. And in this place I can continue simplifying to get 5 over 2. For this I divided numerator and denominator by 2. Or if the answer, or maybe it's just more convenient for me, or the answer is in the decimal representation, 25 over 10 can be written as 2.5. So that's basically all you need to know about operations with decimals. And remember, if you're not sure about that, just use the calculator. Now let's talk about fractions and how to compare them. Well, if you have fractions with the same denominator, you only need to compare numerators, and the greater numerator is, the greater fraction is. And if you have the opposite situation with the same numerators, then compare only denominators, but here is the trick. If that denominator is greater, the fraction is smaller. And the last thing, if you have different numerators and denominators, well, there are 2 approaches you can use. First approach is to get the common denominator by getting equivalent fractions, case with common denominators. But remember that you have a calculator, or maybe you're just good in decimals, and then you can just rewrite your fractions as decimals and compare decimals, which is a lot easier than compare fractions. So let's have a look at the examples here. For the first case, we have 6 over 11 and 4 over 11. Denominators are the same. 6 is greater than 4, meaning that 6 over 11 is greater than 4 over 11. In the second example, we have 6 over 11 and 6 over 21. Here we have same numerators, so we look at the denominators 11 and 21. 21 is greater, meaning that 6 over 11 as a fraction is greater than 6 over 21. And the third example with 3 over 4 and 2 over 3. Well, let's consider both approaches. In the first approach, I represent 3/4 as 9/12 and 2/3 as 8/12. So you see I got the common denominator 12. And now I'd only compare 9 and 8. 9 is greater, so 9/12 is greater than 8/12. Or I could write decimal representations of the fractions. Decimal representation of 3/4 is 0.75. And decimal representation of 2/3 is 0.67 if rounded. And why so we just discussed in one of the examples before. So 0.75 is definitely greater than 0.67, meaning that 3/4 are greater than 2/3. And the last notice for today's lesson is really short. It is how to compare decimals, which to pay attention at. So let's consider the first example with 0.034 and 0.0115. It may seem that 34 is less than 115, but please pay attention at the decimal places. So there is 0 and then 0, they are equal. Then after point there is still 0 and 0, they are equal. And the first number after zeros, second number, it's 1. 3 is greater than 1. So the first meaningful number is greater in the first number, so making 0.034 greater than 0.0115. 115. And in the second example, we still have kind of same numbers, but now decimal point is moved a bit. And the first units digit is greater in the second number. It's 1, and 1 is greater than 0. This brings us that the second number now is greater than the first one. So what you need to remember, consider decimal places when you compare decimals. And that's all for today. Thank you for your attention. We will start doing more complicated problems very soon. And if you still feel not sure with operations with fractions and decimals, I strongly recommend you just to do a few examples to be confident when you have fractions, because we're going to have a lot of word problems having fractions and decimals as part of it, and you just need to be very fast in the calculations. Hope you enjoyed these lessons and see you soon.